Let's just dive right into this. If you've ever hit a brick wall building AI apps just because they can't loop or reflect on their own mistakes, or, frustratingly, remember past interactions, well, you are in exactly the right place. Today, we're diving into this explainer covering Chapter 9, specifically pages 209 through 236 of Building Generative AI Agents, and we're unpacking LangGraph. It's this incredibly powerful open-source framework built specifically for creating stateful, autonomous, multi-actor AI systems.
Here's our roadmap for today. We'll start with moving beyond linear AI workflows, then break down the anatomy of LangGraph, build a reflection agent, explore the power of persistence, and wrap up with the LangGraph ecosystem.
Section 1. Beyond linear AI workflows. So there's actually a pretty stark contrast between standard frameworks and LangGraph. You know how traditional directed acyclic graphs, or DAGs, are strictly linear, right? They move data in one single direction, from point A straight to point B, and that's it, story over. But as developers, we know real-world applications just don't work like that. They require messy, cyclical structures to handle complex routing, dynamic decisions, and actual ongoing conversations. And that brings us to the crucial point here. We absolutely need AI systems that can loop, reflect on what they just outputted, and actually remember past interactions. LangGraph bridges that exact gap. By allowing your AI to iterate and really reason through a problem, it completely shatters the rigid limitations of traditional frameworks. It's literally a game changer for building highly sophisticated, production-ready apps.
All right, moving into Section 2, the anatomy of LangGraph.
First up in the architecture, we have the state. You can think of this as the current snapshot of your application at any given moment. It's essentially the package of data or the ongoing conversation history that gets passed along our roadmap and constantly updated over time. In LangGraph, this state usually takes the form of a Python typed dict or a pydantic base model. Think of it as the memory your agent carries in its backpack every single step of the way.
Next up, we have nodes. These act kind of like the workers or the pit stops on our map. They're the actual Python functions that execute your agent's core logic. So, a node takes that current state we just talked about as its input, performs some heavy lifting, like calling a large language model, and then hands an updated state right back into the system.
And finally, to pull it all together, we have edges. These are the roads connecting your nodes. They're Python functions that route the workflow to the very next node. And this right here is where LangGraph's flexibility really shines. You can use normal edges for direct A to B connections, conditional edges to dynamically decide exactly which path to take based on the AI's previous output, and of course, an end edge to officially terminate the graph's execution.
Section 3. Building a reflection agent. Let's see this in practice.
Now, this setup brilliantly illustrates these concepts in action. Notice exactly how this cyclic workflow is structured. A start node kicks off the whole process, then an edge routes the state straight down to a reflect node. This is where the magic happens. The agent actually pauses to analyze its own output and critique it. After that, another edge routes it right down to an improved node. It's just a perfect, clear visualization of a looping workflow.
Let's trace the exact steps for this Twitter-focused agent. Step 1. The agent drafts a rough initial tweet. Step 2. It reflects and analyzes that tweet for improvements, basically asking itself, hey, is this actually engaging enough? And then Step 3. It generates an improved tweet based entirely on that internal feedback. By continuously looping through these steps, the agent evaluates its own output, takes the critique, and refines it. It vastly improves the quality over time, and all without any human needing to hold its hand.
Section 4. The power of persistence. But here's a massive question. What happens if a complex, multi-step agent suddenly crashes? Or what if it needs to just wait a few hours for a user to provide input? Well, LangGraph solves this elegantly with built-in checkpointers. These checkpointers automatically persist the state of the graph at what the source text calls superstecks. This means your application allows for completely seamless error recovery without losing an ounce of data. It supports long-running processes spanning multiple sessions, and it enables those absolutely critical human-in-the-loop interactions. Your agent can literally pause its operations, wait for you to make a decision, and then recover exactly where it left off. No skipped beats. To really see why this matters, consider a typical travel booking scenario. Step 1. A user starts booking a hotel with an AI assistant. Step 2. The app suddenly crashes, or maybe the user just gets distracted and closes the session. Step 3, the application simply retrieves the specific thread ID from the database. And Step 4, the agent resumes the exact context seamlessly.
Because think about it, if your travel agent forgets your entire hotel request the second you refresh the app, that experience is completely broken. Persistence is the absolute key to making these agents viable for real users.
Section 5. The LangGraph ecosystem.
Now let's talk tooling, starting with LangSmith. This is a platform integrated right alongside LangGraph that lets developers keep a really close eye on application performance. Because look, when you're dealing with agents that are looping and making autonomous decisions in the background, you absolutely need deep visibility. LangSmith allows you to manage traces, track your datasets, and troubleshoot those super intricate workflows directly from one centralized dashboard.
And that naturally brings us to LangGraph Studio, which is a dedicated desktop application. The visual interface here is fantastic. You have your graph structure clearly mapped out on the left and the ongoing chat thread running on the right. It allows you, the developer, to easily edit, step through, and debug your agent loops in real time. You can even inject human-in-the-loop feedback right there in the interface just to test exactly how your agent reacts to unexpected interruptions.
We're going to wrap up this explainer with a really powerful quote from our source text. LangGraph empowers developers to overcome the limitations of traditional DAG frameworks to create advanced AI systems capable of continuous learning and dynamic interactions. And honestly, that hits the nail on the head. The true power of this framework isn't just making an AI talk, it's giving it the structural architecture to actually think, pause, reflect, and improve itself. So, now that you've seen its ability to loop, persist memory, and debug visually, what sophisticated continuously learning agent are you going to build next?